Greetings of the day to all the panelists and participants. My sincerest gratitude to ISDA for allowing us to showcase our research work in front of the world. My sincerest thanks to Nirma University Ahmedabad for providing us all the support we required during this research journey. My name is Harshil Sanghvi and I will present our paper titled NadERA, a novel framework achieving reduced distress response time by leveraging emotion recognition from audio. Now let me start with the abstract of our paper. This paper proposes a novel framework for automatically directing the user to an appropriate helpline number in case of emergency based on his or her emotional state. For emotion detection, we integrate four benchmark datasets. The highest accuracy achieved by the CNN model is 93.14% using the proposed approach. Now let me give you an overview of the entire presentation. First, I will go through introduction, then problems faced, and then we'll give you a glimpse of the literature review we carried out. Then I will showcase the system model and the system architecture which we propose. Following this will be the methodology, implementation, and results of our experimentation. Then I will conclude with some concluding remarks, and finally the references which we have used. So now, to introduce our topic, so let me begin by saying that detecting a person's emotion is really important. Due to several reasons like health application, increasing business reach, user feedback, and making human-computer interaction much more efficient, it is a very essential process. The response times is crucial for emergency hotline services like 911 in United States and 112 in India, where the goal is to deliver time-crucial assistance to its callers. Now, during this, we face basically two main problems. First, during an emergency, callers are usually under a lot of stress, worry, and strain, which makes it challenging to communicate clearly and quickly with the callee. And second problem is that once the correct number is dialed, the health seeker impacted by his emotions is weeping, suffering, shortness of breath, and so on. So during this course, it is to be ensured that all of his information is accurately logged at the emergency services desk so that he receives the fastest possible assistance. But here there is one critical problem, that there is a step of communication between the caller and the callee. So human interaction will always result in a longer response time and delay between the communication. So now we carried out a literature review that what work has already been performed in this direction. We found out that Mehmet proposed a novel hybrid technique based on deep and acoustic features to increase the accuracy, but the system lacks high quality input audio data and noisy environments. Minke proposed a head fusion framework to improve the robustness of speech recognition system and accuracy. The model was built using RaveDes and EmoCap datasets. A transfer learning and autoencoder based one-dimensional deep convolutional neural network based framework was for voice-based emotion recognition were presented by Nivedita and etc. and they obtained 96% accuracy on the test dataset. Now here is the system model for the proposed framework. As you can see on your screen, the person in distress calls on a single helpline number. The audio sample of the caller is processed and features are extracted from the audio. These features are fed into the CNN-based classifier which predicts the emotion. On basis of the emotion detected, it is routed to the appropriate department. For a detailed system architecture, as you can see on your screen, we have modularized the entire framework into four layers: the data preparation layer, the dialing layer, intelligence layer, and assistance layer. Data preparation layer consists of a database formed by aggregating multimodal emotional speech databases. Then the data pre-processed in the data preparation layer is forwarded to the intelligence layer, which trains the neural network architecture on the dataset and keeps it ready for the predictions on the unseen data. In the intelligence layer, the CNN model receives the audio from the distressed caller and predicts the emotion in the call. The call is automatically redirected to the appropriate channel based on the predicted emotion. Now, we are basically considering two categories here: fear and sadness. If the fear is detected, the call will be redirected to police control center. If sadness is detected, then it will be redirected to mental health counselor. And in case of any other emotion apart from these two emotions, it will be redirected towards the general call center. Now, talking about the methodology, there were first two important steps: dataset selection. So for dataset, we used four benchmark datasets: RaveDes, TESS, SAVE, and CREMADI. Revdes is a multi-actor dataset of different emotion audios and it contains of 7 emotions. Save consists of 7 different emotions, same as Revdes. Test consists of 7 emotions like previous two one, and Crema D consists of happiness, anger, fear, disgust, and so on in 4 different speech levels. All the 4 dataset varies in different actors and different gender having their sample voices. In data preparation step, the audio files of each dataset containing different emotions were appended together. All the audio recordings were of 4 to 5 seconds approximately. Further, data was made noise-free by different techniques. Each audio file was then augmented by adding noise where the rate was set to 0.035, stretched by setting the rate as 0.8, shifted by setting the rate as 1000 for both low and high pitches, and then the pitch is set with the rate as 0.7. No class balancing was performed throughout the process. Now, talking about the implementation, we carried out 4 different experiments. Firstly, experiment 1 was carried out using all the features and 7 emotions. Overlapping and averaging audio samples were also performed and an accuracy of 87.74% was obtained. In experiment 2, we made use of all the features and emotion, but the difference was that no overlapping was carried out and only averaging was carried out and an accuracy of 86.83% was obtained. In experiment 3, all the features except IMFCC feature was used and 6 emotions were considered, dropping the surprise class to avoid class imbalancing. Here, no overlapping and averaging was performed and an accuracy of 94.92% is obtained. Finally, in experiment 4, we carried out experiment on all the 7 emotion types with all the features except IMFCC and no overlapping and averaging was performed, and we observed an accuracy of 93.14%. On your screen, you can see the configuration of various experiments performed. It gives us the details of the different features used for different experiments and also the number of emotions considered. It also gives us information about whether averaging and overlapping was carried out or not, and also what was the total size of the feature set for each experiment. And here you can see the architecture of one-dimensional CNN used for the emotion detection process in our experimentation. It consists of series of layers of max pooling, convolution, batch normalization, and so on. Finally, the result obtained by different experimentation is as shown on your screen. The one-dimensional CNN model gave an accuracy of 93.14% on the testing dataset comprising the merged dataset from 4 audio emotion datasets, that is SAVE, Revdes, Cremadi, and TESS. The high performance indicates that the proposed model consisting of 4 differently sourced datasets is highly robust and can accurately recognize the audio emotions of any race, gender, age, and emotion. Now, here as you can see, experiment 3 has a slightly higher accuracy and F1 score as compared to experiment 4. But we need to keep one thing in mind, that experiment 3 just makes detection of 6 emotions. So considering that one emotion is more detected in experiment 4 in trade-off of a very little drop in accuracy, we can say that experiment 4 is a better choice. So concluding to the presentation, this paper presents a novel framework for the automatic and seamless redirection of the distress calls. A one-dimensional CNN model was implemented to experiment on several audio representations. We carried out different experimental scenarios to examine the impact of frame overlapping and frame averaging while extracting features for detecting emotion from audios. In future work, we plan to carry out an extensive research and map different emotions to different departments. We also plan to carry out different dimensionality reduction techniques and also how we can make use of smart and different oversampling techniques. So these are the references of the literature which we made use in literature survey. Finally, once again, I would like to thank ISDA for providing us with this wonderful opportunity to present our research work in front of everyone. A big thanks to Nirma University for providing us with all the support we required during the entire research journey. And now we are open to any questions. You can mail us on our email ID in case you have any. Thank you and wishing you a nice day ahead.